Hello everyone, I'd like to welcome you to this new sessions. So we'll talk about DID, difference in difference. So in advanced data analysis, advanced data analysis, economic we have DID, difference in difference. So we talk about difference in difference. Okay, what is difference in difference? In advanced data analysis, there is economic analysis is there. Under that, we have difference in difference. Data analysis is there. So what is difference in difference? Difference in difference means it's nothing that there is a variable, right? There is a variable called in that variable there are eligible participants are there and other participants are not eligible, right? If you consider participants eligibility as 1 and who not enroll the program, we consider a participant, those participants are 0, right? So it's see the causal difference between that, right? It's see the causal difference between those variables. So that is difference in difference. And how this difference in difference are particularly used through different data analysis techniques, right? If we used R programming, then you have to perform and you have to write some models and perform those analysis through DID, right? Difference in difference. It is nothing but the analysis of causal difference between variables, right? So how it happens is there is suppose before and after. So consider before treatment what the status is, after treatment what the status is. So we see the causal difference between those things. If we need a DID estimator formula, we can write as T after minus T before, then minus T C after minus C before. So we do that. T treatment, after treatment what's the effect, before treatment what's the effect. C in the sense control variables before treatment and after treatment means there is difference, we need to use difference in difference, we need to use those formulas. So there is one thing is there is pre and post also, pre and post, that also we need to remember in DID estimator. So how we will perform in a data analysis if we use R program, right? How will we perform? First of all, step 1 is we load the data, right? First we load the data. Then what we do? Step 2, we select variables. Suppose evaluation data sets, you are selecting treatment locality, and evaluation variable, you are selecting what? Round, before and after case, right? If you are selecting round, you have two variables. Then how you are going to do DID estimator? So first of all, DID estimate, right? How you will call? Suppose DID, you write that DID as it is and call this variables evaluation dollar treatment locality, right, plus this evaluation dollar round. Okay, so we are making DID, difference in different estimators, by what do we call, by multiplying two variables. We are looking for treatment locality and round. There are two variables in a data set. Suppose you consider it, right? So in locality also maybe 0 and 1 is there, round also 0 and 1 is there, right? So we are taking all the variables, all the data inside of that variable, right? We are just selecting evaluation data sets where treatment locality we are selecting, round as a column inside that data set we are selecting, and we are making DID, difference in difference. How we are making, in the sense we are calling first variable multiply, this is multiply, okay, then second variable. So DID is developed. Then what do next? Then DID is developed, right? Next we have to fit into the model. So how model will be DID, right? Estimator 1 equals to what? DID estimator 1 equals to what you do? We have to place in a linear model, right? What? Suppose health expenditure is a dependent variable. So what I do, round plus other variable treatment locality plus what other things is there, treatment locality is there, and one more variable called we develop that difference in different DID also. Then which data sets we refer, evaluation data sets we are referring. It will summary DID estimator 1. So in this case you look for p value and DID value, okay? So our requirement for HISP enrollment program requirement is check those variables inside of it. If it is greater than, then this model is perfect and we can scale up this program nationally. That's a scenario. Means if we get DID as a 6, means this program, suppose in this case I have gotten 6 as a DID, but it is significant. Less than 0.05, it is significant, but DID is -6. So this entire calculation is not good. So has to be near 10 or more than 10 to scale off nationally. Then what's the issues here? Do you know what's the issues? I know the issues because we are taking treatment locality, means there is a data sets inside that Excel file. 0 and 1 coded. 0 means they are not residing in the locality, so we have to look for 1. And here also, round also, you are 1 and 0 is coded pre and post, right? So we need to look at those things. So for that, what we do, we just check the eligibility, right? Eligibility is another column is there. Those people who are eligible for this program, they are only will placed in this model. That's what we should do. For that, what we do, for subsetting, we do subsetting. For that subset, what is the data set's name? That evaluation is the data sets. Then what other thing is there? For eligible equals to 1. So eligible equals to 1 only we are going to interpret, okay? For that we do this and place this and place it in a variable. Say DID dot evaluation. Sorry. Here what we do? We do one thing, right? What we do? We evaluation dot eligible. Okay, only eligible peoples we will place it in our model. So just remember we have developed, we have already created DID, right, by multiplying two variables. So now let's place those eligible candidates only in our model. For DID dot estimated 2 equals to DID dot estimated 2 equals to LM, call that variable is there, right, hospital health expenditure, health expenditure till now, right, round plus what we do, treatment locality plus DID as it is. Okay, now the difference is you are placing this here. Okay, data equals to evaluation dot eligible. Okay, if you summary that, summary DID dot estimate 2, if you summary, you get is significant with DID value is near 10. Okay, near 10. So we are removing, we have what we did before, they were both, right, so programs cannot be scale up and gotten less than 10, but we checked only eligible candidates and it found to be satisfy our need. So we got, if we summary that, if we get more than 10 or near 10 means this program can be nationally scale up. There is one more issue, we have to go with several other variables. Okay, this is estimated, but we need to have several other models. What we do, DID other variables also we need to do, right, DID estimators equals to LM there is one more thing in there, right, LM health expenditure till that, right, health expenditure till that, then round plus treatment locality plus the DID plus, now we are adding all the variables here, and variable 1, variable 2, variable n, then same thing, data equals to data equals to evaluation dot eligible. Okay, data equals to evaluation dot eligible. Data equals to, okay, evaluation dot eligible. So if you summary DID dot estimation 3, suppose we call it as a 3, then we should get P significant with DID equals to 10, maybe more than 10, right? So if you get that, it does not matter negative or positive. If we are getting that, means this program can be nationally scalable. So that's for the final things for this DID, and we need to do for other thing also. That other thing is what we have to check for independent variable also. For that also we need to work out in the same way to accomplish this. So for that, in the next session I will show that in a skill sharing view. Okay, thank you.